Hi there. So this video is going to look at the basic angle rules in geometry. A couple of things that you need to realize first of all is how to label angles. And if we look at this example here, we see that we've got lines and we've got capital letters and some lowercase letters. Generally speaking, the capital letters are at points or at vertices. So this point here would be point A, this point here would be point F, and if you notice that that vertex there, that point there is D, so all in capitals. When you're given some questions and assessments, sometimes they write the actual angle as a lowercase letter. So if you look at this example here, so this angle has been labelled as lowercase a, this angle has been labelled as lowercase b, this angle here has been identified as lowercase c. So when we're labelling our angles, we can label them as angle C, so that symbol there, a slanted L, means angle. So angle C is actually that angle there. It is also labelled angle BCD. So what you do is you start at B, you go to go to C, and then to D, and the angle is this angle in here. So where we've labelled the angle, that middle letter is where the actual angle is the position of the angle. So you need to label your angles like this. The second thing you need to do is recognize the types of triangles. So we've got four types of triangles. We have a right-angled triangle. Okay, so that symbol there, that looks like a step, means a right angle, which is 90 degrees. We have an equilateral triangle. Equilateral triangle. All the angles are the same and all the sides are the same length. We have an isosceles triangle. So with an isosceles triangle, only two sides are the same length, which means that these two angles are called base angles and they are equal. And the last type of triangle is a scalene triangle, where all side lengths are different and all interior angles are different. Okay, let's have a look at all the basic angle rules. So the first rule here, angles on a line add to 180. So if you have a line and you've got angles on the line, so for example we've got four angles, 1, 2, 3, 4. Those four angles add up to 180 degrees. So angles on a line add up to 180. Supplementary angles are angles that add to 180, and complementary angles are angles that add to 90 degrees. The next rule is sum of interior angles in a triangle is 180. So for any triangle, if you add up the interior angles, so angle A, B and C, they add to 180. Vertically opposite angles. So number 3, vertically opposite angles. If you have two lines, as such, the angles that are opposite to each other, so if I call this A and B, they are equal. So A is equal to B. And if I call this angle here C and this one D, then C is equal to D. So C and D are vertically opposite each other and they are equal. The fourth rule is angles at a point. So if I go back to this example here, for angles at a point, A plus B plus C plus D equals 360 degrees. And the last rule we're looking at is base angles in an isosceles triangle are equal. So if we've got an isosceles triangle here, by the way, these two little sticks, those two little lines there mean the sides are equal in length. So at the base of the two side lengths that are equal, that is this angle here and this angle here, those two angles are base angles of the isosceles triangle, and they are equal. So let's have a look at solving a problem. So in this example here, we need to calculate these blue angles. So if you can see the blue coloured angles. So let's have a look at, well, the only angle we're given is this one here, 110. We know that this triangle is an isosceles triangle because these two sides are the same length, which means this angle here, which we've called small b, and this angle here, little c, are equal. So angle B, which is equal to CBD, is equal to, now we've got 110 degrees at this angle here, which means what is left over? 70 degrees. So 70 divided by 2, which is 35 degrees. The reason you'd use there is base angles. So you can use this symbol, the slanted L looking symbol, for angles. Base angles, isosceles triangle. Okay, we can now work out A, which is this angle here. So angle lowercase a, I can also label that angle as ABD. So angle ABD. And that angle is on a straight line with B. So angles on a straight line add to 180 degrees. So I know that B is 35, which means angle A is equal to 180 minus 35 degrees, which is 145 degrees. And the reason for that is angles on a straight line add to 180. Okay, let's look at angle C. So just scroll up a bit. Angle C is, and that's lowercase c, so if I was to relabel it, it would be BCD. So angle B, capital C, D is 35 degrees, so that is base angles in isosceles triangle. Let's now work out this angle here. So we would label that angle EDF. So angle EDF, okay, which is this angle here. That is vertically opposite to 110. So that angle is 110 degrees, and the reason is vertically opposite angles are equal. The last couple of angles are these two here, so that one and that angle there. So If I just scroll up a wee bit more, so this angle here we would label BDF. So angle BDF is equal to, if you look at the diagram, it's on a straight line. We know that this angle here is 110, so this angle must be 70 degrees. Okay, and that's angles on a straight line, add to 180. And then the last angle we're finding is angle CDE. Angle CDE. Okay, so which is this angle here. That is vertically opposite to that one there, which we've just found out is 70. Therefore, this angle is also 70. And the reason is vertically opposite angles. If you'd like to have a go at an example, here is one here. So have a go at that, draw the diagram, and then I'll put the answers up on this video in a minute or so. So just pause the video at this point and have a go at calculating these coloured angles here. So the purple one, the blue one, yellow one, pink one and green one. So here are the answers to that problem. We've got the blue angle here, angle ADB is 70 degrees, and you can tell that this is an isosceles triangle, so that angle there must be 70. This triangle, the interior angles add to 180, so if we've got 70, 70 there, that makes 140, which means that this angle must be 40 degrees, so angles in a triangle. Knowing this blue angle here, angle BDA, is 70, the angle vertically opposite it must be the same. So this pink angle here, angle EDF, is also 70 degrees. The reason is vertically opposite angles are equal. Then we have a straight line here, which means that yellow dot there, representing angle ADE, must add up to 180. So this angle here, the pink one, the pink dot, is 70. Therefore, this must be 110, so that those two angles add up to 180. Then the last angle, this green one here, angle HEG, due to the fact that angle CED is a right angle, that must also mean that CEG is also a right angle, due to the fact of being angles on a straight line add to 180. So that also must be, that angle there, must be 90 degrees. So if this angle is 20, this angle must be 70 degrees. So the reason for that is complementary